Everything you can see, every star, every planet, every galaxy, every atom in your body makes up less than 5% of the universe. And nobody knows what the other 95% is. Welcome to the Cosmos in 5. Today we tackle dark matter, the invisible substance that makes up about 27% of the universe and holds galaxies together without ever interacting with light. In the 1970s, astronomer Vera Rubin was measuring how fast stars orbit the center of galaxies. According to Newtonian gravity, stars far from the galactic center should orbit slowly, just as Pluto orbits the Sun more slowly than Mercury. But Rubin found something shocking. Stars at the outer edges of galaxies were orbiting just as fast as stars near the center or even faster. The galaxies were rotating in a way that simply made no sense given the visible mass inside them. The only explanation that worked mathematically was that galaxies are embedded in vast halos of invisible mass, mass that contributes to gravity but doesn't emit, absorb, or reflect light. This missing mass is called dark matter. Galaxy rotation curves were just the beginning. Gravitational lensing, the bending of light from distant galaxies by the gravity of foreground objects, reveals mass that cannot be accounted for by visible matter alone. The bullet clusters, two galaxy clusters that collided and passed through each other, dramatically showed dark matter separation from normal matter. The hot gas from the two clusters smashed and slowed down, but the dark matter halos passed straight through each other without interacting, observable through lensing. The cosmic microwave background, the faint afterglow of the Big Bang, also contains statistical patterns in its temperature variations that precisely match a universe containing dark matter. Multiple independent lines of evidence all point to the same conclusion: something invisible, something we cannot detect directly, makes up more than 5 times the mass of all the visible matter in the universe. If dark matter can keep whole galaxies together without showing up, your like, share and subscribe can keep this channel going strong. Hit those buttons and let's keep the cosmic adventures rolling. We genuinely don't know what dark matter is. The leading candidates includes WIMPs, weakly interacting massive particles, which would interact with matter only through gravity, and the weak nuclear force. These are also axions, sterile neutrons, and primordial black holes. Despite decades of searches using incredibly sensitive underground detectors, colliders, and space telescopes, dark matter has never been directly detected. Every attempt has come up empty. It remains the biggest unsolved problem in observational physics. Here is what keeps physicists up at night. We have overwhelming evidence that dark matter exists, but after 50 years of searching, we have no idea what it is. What if it's something so fundamentally different from anything we know that our current physics simply has no category for it? What would it mean if we found it tomorrow?